Chapter 7, Part 2, Day 4, I believe. So there's 30 students in Mr. Cooper's class, 18 boys and 12 girls. Mr. Cooper chooses a student at random to present his or her solution in front of the class. 4 of the boys and 3 of the girls have already presented. So create a two-way table of this data. Alright, so let's see here. So I believe that, let me make this, I don't know, that didn't go well. Alright, let's just do this then. Let me pause and set this up. What I need to do here is we're going to say there's boys and girls, and we're going to say they've either presented, I think I misspelled that, so we'll say they either presented, that didn't go well, jeez, presented, we'll say yes or no. Alright, so let's see, there's 30 students in the class, that's a total, 18 boys, it doesn't say anything about whether they presented or not, 12 girls, it doesn't say anything about whether they presented or not. I choose a student randomly present his or her solution in front of the class. 4 of the boys and 3 of the girls have already presented. So 4 of the boys and 3 of the girls have already presented. So that means 7 have presented, which means there's 14 boys and 9 girls that haven't, or 23 altogether that haven't. So again, I hope you guys are pausing these videos and trying this stuff for yourself. So obviously the total's on the outside. Sometimes two-way tables have probabilities for entries instead of counts to make it easier to solve the problem. Make a new two-way table, but this time use probabilities instead of counts. So I guess what they want us to do is, I'm not sure if they want us as a percent or not. Let me pause and see if they want this as a percent or just fractions. These as fractions, I guess. So I'll just, I think the easiest way would be just to make them out of 30 and do it that way. Okay, if Mr. Cooper randomly selects a student, what's the probability he selects a boy who has already presented? It looks like a 4 out of 30, right? If a student is chosen randomly, at random, what is the probability the student is a girl, there's 12 girls, or is a student as presented previously? There's 7, so 12 girls plus 7 presenters is 19 minus the 3 girls that have already presented, because we don't want to count that twice. We're going to say 12 plus 7 is 19 minus 3. Let me pause for a second. Alright, so that's going to be 16 out of 30. Or we can just add up 4 plus 3 is 7, plus 9 is 16. Either way, we're going to get 16 out of 30 there. It says, if a student previously presented, so these are the people that have presented, what's the probability it's a girl? We'd say 3 out of 7. Again, that's that concept of conditional probability. None of these people matter because these people haven't presented yet. We're only worried about the people who have presented. So there would be 3 out of the 7. Alrighty, let me pause and set up the rest of the video. It's a little bit tricky, so feel free to try and pause it and see what you come up with. But it says, if Letitia studies for her math test tonight, she has an 80% chance of getting an A. So she's either going to study or she's going to get an A. Those are really the possibilities here. Now it says, if Letitia studies for her math test, she has an 80% chance of getting an A. So if she studies, she has an 80% chance of getting an A. If she doesn't study, she only has a 10% chance of getting an A. Right? So that would mean that so a couple things going on here. So first of all, if she studies, 80% chance of getting an A, which means a 20% chance of not getting an A. If she doesn't study, she has a 10% chance of getting an A, which means that she has a 90% chance of not getting an A. But here's the trick. Early in the day, her father said there's a 50% chance that she'll be able to study. So we know that there's a 1 in 2 chance of being up here and a 1 in 2 chance of being down here, which means all of these have to get cut in half, right? So this would actually be a 40% chance. This would be a 10% chance. This would be a 5% chance. And this would be a 45% chance. So hopefully that makes sense as to why, right? Because if you think about it, that's still 4 out of 5. That's still 80% chance of getting an A. And this is still, 1 to 9, or a 10% chance of not getting an A. So if you add those up, you can see these are what the percents are going to add up to. So really tricky to fill this one in. So it says diagram for the situation. What's the probability that she gets an A on her math test? Well, there's a 45% chance she's going to get an A on her math test. What's the probability that Letitia studied, given that she earned an A? Well, if we say that she earned an A, then there's a 40 and 45 chance that she studied, which is an 89% chance. So if she studied, she's probably going to get the A, right? But if she doesn't, she won't. Anyway, there's a lot going on in this problem. Hopefully that makes sense as to why. First of all, the 50-50 chance of whether you study or not is one thing, but then you have a different odds of the top happening versus the bottom. So